Hello everyone, welcome to our channel. In this video, we are going to see chapter 1 real numbers exercise 1.3 question number 1. So, for proving a number to be irrational, we have to use a contradiction method. In your textbook, they have used a contradiction method to prove a number to be irrational. So in the question number 1, they have given prove that root 5 is a irrational number. So irrational number, for that we are going to take root 5 as a rational number. That is, we are assuming root 5 to be a rational number. So rational number will be of the form P by Q. And we are going to see a term co-prime. So co-prime is that when two numbers have their highest common factor as 1, they are said to be co-prime numbers. Say for example, if we take 3 and 5, when we do prime factorization method, we will have 3 one time and 5 one time, as they both are prime numbers. So if we check with both these numbers, their HCF will be 1. Such numbers are said to be co-prime numbers. If we take another number, say for example 2 and 4, if we do prime factorization for 4, we will get 2 times and 2 one time. So here the HCF of these two numbers will be 2. So they have their highest common factor as 2. So these two numbers are not co-prime numbers. So co-prime numbers are those numbers whose HCF is 1. So in this question, first step is we are going to take root 5 as a rational number. So we know that rational numbers will be always in the form P by Q. That is, here I am using the terms A and B. So we will take integers, A and B, where A and B are co-prime. So we have written here root 5 is a rational number. So therefore root 5 will be equal to A by B, since rational numbers will be of the form A by B. Now I am cross multiplying this B so that this B will come to the numerator part. So I will have A equal to, when I bring this B to this side, I will have root 5 B. I take this as the first equation. Now I am squaring both sides. Squaring both sides, I get A the whole square equal to root 5 into B the whole square. So I will have A square is equal to 5B square. Now I bring this 5 to the left hand side and I will get A square by 5 equal to B square. So this means that A square is divisible by 5. Or we can say 5 divides A square. We can say the either way. Therefore, A square is divisible by 5. Or we can say 5 divides A square. Therefore, now I am using the theorem, by theorem 1.3. So what is the theorem 1.3 is, let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. So here we have to write the theorem. Let P be a prime number if P divides A square, then P divides A, where A is a positive integer. So here what we have written is A square is divisible by 5. So by using this theorem, I can say A is divisible by 5. And I take this as the second equation. I say this as a second equation. Now I am taking A equal to 5C. That is, here they have given A is divisible by 5. We have, by this theorem, we have written A is divisible by 5. This means that A will be equal to 5 into some integer value. That is, when I take A is equal to 5C, it means in place of C, if I put 1, what I will get is 5 into 1, 5. And in place of C, if I put 2, I get 5 into 2, 10. So, these numbers 5, 10, likewise I will get 15, 20, 25, 30. All these numbers are all divisible by 5. So, as given in the statement, I can write A equal to 5C. Now, from the first equation, what we have in the first equation, A equal to root 5B. So, from the first equation, in place of A, I am going to put 5C. So, taking A equal to 5C in equation 1. So, I will have 5C is equal to root 5B. Now, again, as we did before, we are going to square both sides. Square both sides, I will get 5C square is equal to square root of 5B the whole square. So, I will have 25C square is equal to 5B square. Now I am going to bring this 5 to the other side, that is to the left hand side. So 5 will come to the denominator part. So what I will have is 25C square by 5 is equal to B square. So I will get, if I cancel this, so I will get 5C square is equal to B square. So therefore, by theorem 1.3, again I am using the theorem. So by theorem, if B square is divisible by 5, B is also divisible by 5. And this I am taking as 3. So from 2 and 3 statement, I can say that 5 divides both A and B. So A and B have a factor 5. So what we can say, so 5, the HCF of A and B is 5. But what are co-prime numbers? Co-prime numbers have HCF as 1. So we have told in the statement, in the first statement, that A and B are co-prime. But here we have got that A and B are not co-prime. Therefore, A and B are not co-prime. Hence, our assumption is wrong. Therefore, by contradiction, we can say root 5 is irrational. We can say root 5 is a irrational number. And this is how we have to prove root 5 is a irrational number. So the same step will be followed for proving root 2 and root 3 as irrational, as they have given in the example sums. In the next video we will be covering the next sum. Thank you.